Hello and welcome to Autodesk Simulation TV. Today's topic, simulation in action, pressure vessel design, design and validation. My name is Mike Fiedler and I'm going to work with you on today's topic. So the problem description that we have for today's topic, we're going to take an exercise and we're going to look at what sort of tools are in the software to help you model this pressure vessel, and then once you have it modeled, how do we analyze that particular vessel and what do we have to look at in results? Or more specifically, what are our learning objectives? How to use the PV utility to create the vessel. So within simulation software, there is a PV design module, and that module is going to help you design the pressure vessel quickly and also accurately. Our next objective, how do we apply loads and constraints to the vessel? So of course we need to have some sort of constraints to keep that vessel from moving all around. And then what sort of loads do we want to apply? Is there thermal loads? Are there pressure loads? And then loads and constraint considerations. So when you're analyzing something like a bracket, say that's static on a wall, and you know that you're going to hang something from that bracket, you have a static load, you know what that load is, you know what the load maximum is, for instance. With a pressure vessel, you might have also considerations for thermal analysis, you might have some sort of cycling involved with it, so there are additional considerations with pressure vessels, and we'll talk about those as well. And then we're going to analyze the vessel so that we can look at some of the results. So in our results, we're going to have our typical results, displacement, stresses, and then there's also some unique tools centered around pressure vessels as well. And we'll talk about and look at some of those. So let's go ahead and jump into the software so we can begin taking a look at our pressure vessel design. Okay, so now that we have the software open, to access the PV Designer module that I was talking to you about, we can either go to the Application pull-down menu and we're going to say New, or of course we can just access the New button right from the ribbon bar. So there's an option right here which many of you may not have noticed unless you're actually looking for it, and that item right there says PV Designer. So that's the icon that we're going to go ahead and select in order to launch the pressure vessel design module. And I'm going to go ahead and say New, and then I'm going to go ahead and assign some sort of name to our model. After assigning the name to the model, a dialog is going to come up and it's going to say what sort of units do you want to generate this particular pressure vessel in. I'm going to go ahead and accept what is the defaults on my system, which is the English inch unit system. We'll say OK to that. And then our pressure vessel design module opens up. So it's kind of a really neat utility in my opinion. Over here on this side, this gives us all the options where we're going to input the information to create our pressure vessel. And then as we do that, over here we have a visual of what's happening with the particular design. So first of all, going down to menus here, you'll see what type of model to generate, whether you would like to do a single nozzle or multiple nozzle. We are going to do a multiple nozzle design, but for the moment I'm just going to leave it on single nozzle just to show you a couple quick changes so that you can see how the image is going to change for us. Below that you have the option of what sort of pipes do you want to generate. Do you want to generate a plate shell, or do you want to generate a solid? So the program is able to generate either. In this particular example, what we're going to do is something that is plate shell. The vessel is relatively thin relative to its overall length, so the plates are better able to simulate something like that. But there are cases where you might want to use solid elements. For instance, if you're going to use something like stress linearization, i.e. you're going to use pressure vessel code, and you need to take a look at membrane plus bending stresses, we have a utility in the results environment that allows you to do that. So in that case, if you're looking, for instance, at the nozzle to the vessel connection and you're going to use stress linearization, there you might want to utilize brick elements so you can execute that particular utility. But in this case, again, we're going to do plate shell. Below that, you have an option, how do the pipes intersect? Do they intersect at 90 degrees to one another, the nozzle to the main pipe, or along a specified direction? If you look across the top here, I have several different options. Right now we're on the General tab. We have a Geometry tab, and the Geometry tab is where I define, say, the diameter of the vessel, the length of the vessel, and then just to the right of that you'll see an Intersection tab, and the Intersection tab is grayed out. Currently that's because we've told it that we're going to intersect at 90 degrees, but if I say along a specified direction, then my Intersection tab will become highlighted. And then lastly, we have flanges and repad. So let's quickly take a look at some change. So if I go over to the Geometry tab, for instance, there you'll see diameter of cylinder, and it has some dimension. Let me just go ahead and quickly change that. Right now it's set to 5 inch. So let's say that I make that 12 inches, and as soon as I tab down into the next field, you can see how the preview updates for me. So just a quick introduction to the utility before we begin to generate our particular vessel. Some of the other things that I would call your attention to right across the top where the icons are here, we can change views on that model if we want to look at it from a different angle. We have ability to change the mesh that's on the model. We have ability to add heads onto the model. And we're going to do all those sorts of things as we go along with this particular example. Before we begin, one last comment I would make about it. Why do we have a pressure vessel utility? One of the things that you'll note, just looking at the mesh right here, we have a very uniform mesh here, nice quads, nice aspect ratio to the quads, and of course we have a nozzle coming down and it's intersecting with that vessel. So we have to do something with the mesh at that intersection between the nozzle and the vessel itself. So you can see that we have a transition mesh here, and even in that transition mesh, we still have quad elements, but then it transitions in size and a little bit in shape so that it can properly make that connection between that two. And that is really part of why the pressure vessel design utility is here, is it so that you can create the pressure vessel for one, make it nice and simple to create the vessel, and then two, to give you a high quality mesh on that geometry. So what I'm going to do is go ahead and flip back to the General tab here, and we'll begin on the construction of our model. Our vessel is going to be 10 feet long. We're going to add a main nozzle to it, or a primary nozzle to it, that's going to be approximately 12 inches in diameter, and then we'll add several smaller nozzles in addition to that, just to make it kind of interesting. So since we have multiple nozzles, the first thing I do on the General tab is I'm going to change from a single nozzle to a multiple nozzle design. And now when I do that, you'll notice that all these tabs gray out, and this icon, or this button right here, becomes available for me that says multiple nozzles. So on a multiple nozzle design, we must go ahead and click that so we can get in. And now I get another pop-up window, and the pop-up window is where I'm going to define all the sorts of information that I just showed you on the other tabs. What's the diameter of the cylinder, diameter of the nozzles, and so forth. So first of all, the length of our cylinder. I said we're going to do 10 feet, so we're going to make this, remember I'm in terms of inches, so I'm going to do 120 inches. And then what is the diameter? You can notice in the background how that extended, updated the preview. What's the diameter of my cylinder? In this case, it's 4 feet in diameter, or 48 inches is going to be my input. Okay, let me go ahead and enclose that. Move that window aside so you can see what we have so far. The next thing that you can do is add a taper angle to your nozzle if you would like. In our particular case, we're just going to make it a straight cylinder. Let me go over to the next tab here. There's my extras. So I can include flanges on the main body of the cylinder. You can see it says include a flange at the negative end of the cylinder, include a flange at the positive end of the cylinder. So if I move out of the way a little bit, you can see here's our mini axis. So the axis of my vessel is along the X. So negative end would be in the negative X, positive end would be in the positive X. There's also a button here for heads. We are going to put heads on this, but we'll come back to that in just a little bit. On the next tab, you have your mesh. So you can really control the mesh divisions. You can see it says mesh divisions along the axial direction of the cylinder. By default, it's at 40. I could increase that if I wanted to. Mesh divisions along the sweep direction of the cylinder, also at 40. I could increase or decrease that value. So you have a lot of control over what sort of mesh divisions. And then on the next tab here, parts. So what part numbers are being assigned to the various parts of your geometry? Is the nozzle on a particular part, which happens to be a different part than the vessel, which happens to be a different part than the flange? So the program will do that for you automatically, which is a really nice feature. We'll talk more about that once we have the model completely generated. Let me go back to the Geometry tab, and let's begin to add our nozzles on this model. So what I'm going to do is say add a new nozzle, which gives me a nozzle dialog. We want it to be a round nozzle versus an elliptical or rectangular, but you see that you have a lot of different options here. We're going to make it a round nozzle. The diameter of that nozzle is going to be 12 inch. The length of that nozzle, I'm going to make that 6 inches. The next item down is the taper angle. I don't want to change the taper angle. Inside length of the nozzle, so I can extrude that nozzle into the inside of that pressure vessel. I'm not going to go ahead and do that. In this particular model, it's going to terminate right at the outside surface of the vessel. And then below that is a checkbox for orifice with no nozzle. So if I just wanted to make a hole in that vessel, an inlet or an outlet, you could do that as well. On the next tab, so now I've defined its geometry, what's its dimensions, its size. On the next tab is my position. So I define where it is along the axis of this thing. Whenever you're doing a multiple nozzle model, the far end of the vessel in the -x direction actually begins at x equals 0, and then since I made it 120 inches, these ends of the model, these nodes out here, that would be at 120 in the x. So that tells me, or gives me some indication of where I need to position my nozzle. For this one, I'm going to position it right along the middle of this model, along its axis, so 60 inches in the x value. And then rotation, you can see that it showed up right over here. Maybe I should pan that over a little bit if I can. Not with this particular dialog window up. That's okay. You might be able to see a little white nozzle showed up right there. What is my rotation? In this particular case, we're going to rotate it -90. And the next thing would be the offsets. So I have, again, the ability to position it at an angle off from the center line. There's your angle input, AR, DY, etc. All right, so we're not going to give it any sort of offsets, but it's pretty simple to follow. You can see nozzle offset distance, DY. That is this next input right here, DY. And then right over here, there's a schematic on the right-hand side here. So you say, okay, what is DY? Well, there's my offset angle, and then there's my DY offset distance, okay? So that makes it pretty simple to do. We are going to go to the extras page, or tab, and on the extras tab, we want to include a flange on this nozzle. So I'm going to go ahead and say that I want to include a flange. Then on the flange, right below when you say include flange, that opens up this field here. What is the width of our flange? So for a 12-inch diameter pipe, the flange width is going to be 4.25 inch, and that's based on a class 300 flange, so we'll say 4.25 inch for our width. And then you also have the ability to add a repad on the nozzle. In this particular case, I'm not going to add a repad, but you certainly could, and then you could assign its width for that repad, and then ultimately the thickness of that repad. I'm going to go ahead and say apply and OK. And I'm going to say OK to this dialog window cylinder with multiple nozzles, just so you can see what we have built so far. So there is our 12-inch diameter nozzle. There's the flange that we've added to it. So we're going to add a couple more nozzles onto this system. So how do I do it? I just go ahead and click on the multiple nozzles. That gets me right back into the dialog screen. Now that I'm in this dialog screen, I have a couple different options. What if you say, well, I don't want that one to be 12 inches. I wanted it to be 8, or I need it to be 10. Somebody comes along a little bit later and says, we need to change this design. You do have a modified nozzle, and it's the first nozzle that I put on there. So if I hit modify nozzle, that'll go right back into that dialog screen. And there you can see the 12-inch on the diameter, the 6-inch on the length. So you can adjust either one of those. So don't be worried if you have to make changes to it. I don't need to make any changes. I just need to add some new nozzles. So in the new nozzle, we're going to make it a round nozzle. The diameter of it, we're going to make it 4-inch. The length of it, we're going to make that 6 inches. No taper, no inside length. So what I need to do is position it. In the X, I'm going to make it 12 inches, or 1 foot over from the very end of our vessel. The rotation on this particular nozzle, it's going to have 0 degrees rotation. We'll give it some extras. Again, we're going to include a flange, and the width is going to be 3 inch. So apply and OK. I'll say OK again so you can see that. OK, so there's the one we just added. OK, 12 inches in from the end, 4-inch diameter, 6 inches in length. So you can see where if you're not going through and explaining all this as you do it, if you're just coming in, you're sitting at your desk, you need to build this vessel. If you're just inputting data, very quickly you're generating this geometry. So I would say it's competitive, perhaps even better than if I tried to do this with a CAD solid modeling program or some sort of surface modeler, and I was creating a circle and I'd have to extrude it upward for a certain distance, and then I'd have to extrude it down to the vessel and trim that surface and so forth. So it's pretty quick to utilize utility. Let me, excuse me. Let me go ahead and add another nozzle. I'm going to say add new nozzle. It's round. Again, diameter 4 inches. This is going to be 180 degrees from where we just put the last one. The length of it's going to be 6 inch. Its position, 12 inches along the X. Its rotation, I'm not going to worry about just yet. The way I'm going to do it is with an offset angle. So with the offset angle, I'm going to give it 180 degrees. Okay. And we'll say okay. Whoops. Oh, sorry. Let me make that 0 and give it an X rotation of 180. Okay. Okay, so there's our nozzle. I just came out to confirm. What we probably also want to do is add a flange onto that nozzle like our other ones. So again, we'll just click on multiple nozzles. And now I want to modify that one, right? I want to add additional things to it, the flange. So what I'm going to do is select the third nozzle that I've added. I'm going to modify it. And then I'll go right over to the Extras tab, where I can say include a flange. And the flange width, again, is 3 inch for that particular diameter. And okay. All right, so at this point we have all the nozzles and flanges along the vessel that we'd like. The last thing that we're going to do is add some heads onto this particular vessel. So let me go back into the multiple nozzles. I'm going to go over to the Extras tab. On the Extras tab, again, this is where we can include flanges, or we can include heads via this button right here onto our vessel. So I'm going to go ahead and say that we want to add heads onto the vessel. The type of head, there's two different tabs here, so we can define what's on the negative side and what's on the positive side. I'm going to do the positive side first, so as I generate that, you can see it being built on the positive side of the cylinder. So type of head, first of all, there's none, so if you just want it open, you can do that. And then below that, you have options of flat. You have spherical, ellipsoidal, toruspherical, and conical. So depending on which one of those you choose, i.e. if I just choose a flat, you're going to have different input options down below here. And actually, I'm on the negative side, I see now. I never actually clicked the tab. So if I say flat, there you can see the flat head come in. And then you have the different options for input depending on what's necessary to define that particular head. So in our case, we're going to choose a toruspherical. And so what I need to define is whether it's concave or convex, and then spherical radius and knuckle radius. So for the spherical radius, we're going to make that 40 inch. For the knuckle radius, we're going to make that 10 inch. And then I have the option to add additional length in, that is to extend it from the main vessel. Why might I want to do that? I'm going to go ahead and do that. I'm going to make that 2 inch, for instance. So it just added this little strip. You can see this finer mesh here. So maybe what's happening here is I have a certain thickness here in the main body of the vessel, and then as we get into the head, maybe right here I have a different thickness, an increasing thickness, and then maybe some different thickness in the head itself. So that way, by defining the different parts, I can assign the different thicknesses of the plates. So that's all we need to do on the positive side. On the negative side, we're also going to make it a toruspherical head. Again, same sort of input, so the spherical radius is going to be 40 inch. The knuckle radius is going to be 10, and I'm going to add 2 inches to it. And we'll say apply to that. Okay, one last thing that we're going to do in the geometry generation, and that is that we're going to define a nozzle on one of the heads. So you can do that as well. So just showing some of the flexibility. Not only can we add nozzles along the length of the pipe, but you can also do it to the heads as well. So in order to do that, down here there's a little checkbox that says include nozzles on the head. Actually, before I do that, let me say OK, and we'll reposition our model. Let me say OK again. And I want to take a look at, say, a YZ view. There we go. And I'll move my model down a little bit so that as I generate, you'll be able to see it generate. I'm going to go back into multiple nozzles. I'm going to go to the extras. I'm going to go to heads. And working on the negative side head, which is this red one that you see here, I'm going to go ahead now and say include nozzle on the head. And I'll just go ahead and click nozzles on head. So you can see as we do this each time, whether we're defining the vessel or whether defining heads or nozzles, it's just a matter of simply inputting the particular dimensions of that feature and where it's positioned. So in this particular one, we're going to do a round. We're going to call it 6 inches as in diameter. As far as the length of that's concerned, let's make that about 6 inches in length as well. Inside length, I'm going to leave that at 0. As I've done that, you can see that it positions right here. What we want to do with this is offset it a little bit. So I'm going to go over to the position tab. My offset angle, I'm going to make that 180 degrees. And the offset distance, I'm going to make that, say, 18 inches. And we'll say apply. Okay. So from the center, if I would have made it 18 inches, it would have gone up this way. So that's why I gave it the offset angle of 180, so it comes down towards the bottom of the vessel. And then last thing we're going to do with that guy is what? We're going to give it some extras. We can give it a flange, and our flange width for a 6-inch diameter is going to be 3.25. We'll say apply and OK. All right. So I think we have a pretty respectable vessel generated there. So you can see that quickly we've generated the vessel, we've added heads, we've got 4 different nozzles on it, including one on the head itself. So again, I think it's a really nice utility to quickly generate that geometry. Okay, now that we have the vessel completely defined, what we want to do is transfer it back to the FEA editor or move it into the FEA editor so that we can do our analysis on it. So via the File pull-down menu, what I'm going to do is click Done. And what that's going to do is open up the model now in the Autodesk simulation environment. As soon as I have the model in the simulation environment, one of the first things that you'll notice about it, if you look down the menu tree on the left-hand side, one of the really nice features of the pressure vessel design module is that it places different features of the model onto different part numbers. So for instance, if I just single left click on part number 1 in my menu tree, you can see that it highlights the main body of the vessel or the cylinder. If I click on part 20, for instance, that's one of the heads on the model. So it's a really nice feature. And the element type is already set for me as plate. So what comes next after that, if you were to follow down the sequence in the menu tree, would be the element definition. And it's within the element definition screen for plate elements that I can define what the thickness of the various parts are. So that's what makes it really interesting, what makes it really nice and easy to set up a model with different thicknesses, is that I can find the specific element on my pressure vessel and then define a different thickness for it. In this particular model, we're going to keep it rather simple. Let me zip up all the parts. We're going to select all the parts, and then I'll just right click and I'm going to say I want to edit, and I can edit the element definition. We're going to assign them all a thickness of 3/4 inch, 0.75. Once I have the thickness defined for each one of those parts in the assembly, the next thing that I can do is go to edit, and I'll assign the material. For this assembly, I'm going to take an ASTM A514, and we'll say OK. Now, what you do with the model next really depends on what you're looking for from the pressure vessel. Of course, we might have considerations for thermal, so we might want to take a look at, when I heat this part up, what does the distribution in the thermal analysis look like? Or maybe I want to see a thermal stress, so I could run a heat transfer analysis on it. Then with this thing at an elevated temperature, how does that expand, contract? What does that do to the stresses in my model? You could take a look at something like a transient thermal, so you could look at a time-dependent analysis and then likewise take that into a mechanical event simulation where you're looking at time-dependent stresses. And then you also have to consider something like, what if over the lifetime of this thing we're going to pressurize it and depressurize it, or we thermal cycle it a number of times? Then you might get into something like a fatigue analysis. So you could include your temperatures, you could include whatever forces and constraints are on the model, run a solution, whether that's a linear static stress solution or a mechanical event simulation solution. Once you have those stresses and displacements, then you could push it onto a fatigue analysis, and then in that fatigue analysis you could determine then how many cycles the structure can withstand. Again, what we're going to do here is just a simple linear static stress analysis. I've already defined my thicknesses and my materials, so what I yet need to do would be the loads and the constraints. What I can do is go into a point select or rectangle select in conjunction with select vertices, and if I move over to the vessel, the main part of the vessel here, and I take two adjacent points on the mesh and I right click and inquire, I can see that that's about 3 inches between each one of the elements. So I need to constrain the model somehow. We can imagine perhaps that this is in some sort of saddle support and it's on a stand. So maybe those stands would be, let's say, 2 feet in from the edge. What I can do is kind of count over on the model. Let me rotate this a little bit more. That's not exactly the orientation I wanted. That's it. What I can do is count over 3, 4, 5, 6, 7, 8 elements, and then I'll take the vertices adjacent to that. Now that I have those vertices selected, I can right click, add my nodal general constraints, and we're going to make those fixed. Likewise, I'm going to do the same thing from the other side of the model. So again, I'll count over 1, 2, 3, 4, 5, 6, 7, 8, and then just grab the nodes again, add nodal general constraints, and say fixed. Now, how elaborate you want to be with that is really up to you. Of course, once you're within the FEA editor, before we execute the analysis, what I really have is a series of lines and nodes. So certainly I could take lines here and I could copy them down, extrude them, copy, join them to create something a little more representative of the saddle. I could take these lines here and I could modify them onto another part yet. So I could duplicate them onto a new part number that it has not been used yet, and I can assign them a thickness, something representative of the stiffness of the saddle. So there's a lot of different options there. Again, we're trying to keep it relatively simple. Last thing that we're going to do for the setup of our model is to apply some sort of pressure to it. So I'm just going to box select our model so that we select all the surfaces, and then we'll right click and we're going to say that we want to add some pressure to it. So I'm going to do surface pressure, and we're going to do about 250 psi. Okay, so you see that once you get the model out of the pressure vessel design module, what you do with it in the FEA editor is very similar to how you would set up any other analysis, your considerations for loads, constraints, materials, and so forth. Next thing we're going to do is just execute the analysis. It's plate elements, 1 element through the thickness of the model times X number of elements over the entire model, so it's pretty quick to run the analysis, approximately 8 seconds on my machine. All right, and there we are into the results environment. You can review anything that you would typically review with any other analysis. Here we're taking a look at displacement magnitude, so you can see a maximum displacement of about 0.11 inches. Of course, we'd want to take a look at the von Mises stress, and the von Mises stress for this model is just about touching 36,000, so that might be something of concern. We'd want to look into a little bit more. Particularly, you can see around the nozzle to vessel connections. And while we're taking a look at that, one of the other things that I mentioned a little bit earlier, whenever we were going over the introductory slides, other considerations for this model. So there is also a stress linearization utility, not the concentration of this particular demonstration, but there's a stress linearization utility that allows you to take a look at the stresses across a section, take a look at membrane plus bending stresses so that you can compare those to code. Speaking of membrane and bending stresses, because we did use plate elements, there is one other option that we should take a look at here, and it's under the settings pull down menu. So if we go to the settings pull down menu, you'll notice there's an option there called Plate Chill Options. So if we go to Plate Chill Options, if you're not already aware of it for plate elements, by default, whenever we're displaying something like a von Mises stress, we're taking a look at total stress, or if you were looking at, say, a von Mises strain, then it would be the total strain. But you can separate those out. So if I want to take a look at or interrogate just the bending stress in my model, just come one radio button down. I can see that the bending stress in this model is about 31,000 psi. Likewise, you can take a look and just interrogate the membrane stresses that are in your model. So I have a little bit of both going on. Membrane stresses coming from the internal pressure, and bending stresses primarily arising from where the vessels, flanges, and nozzles are in the model. Okay, so that about does it for what we're going to do inside the results environment and setup with the model. So let's go to our closing slides now. Okay, now that we've completed our exercise, in summary, whenever you're designing pressure vessels, take advantage of the PV Designer utility that's within the software to help you generate that vessel. Consider the various types of loading that you have within that vessel, and then leverage the software to evaluate the results with all the different types of results options that we have available. Thank you for tuning in today. Feel free to reach out to the Simulation Squad if you have any further questions. Thank you.